Hi, it's Richard here. I just want to share with you the issue I'm having right now with my pool filter pump. It's not working, and I'm going to turn it on to let you hear what's going on. Just hold a second. You can hear that hum, but the pump is not turning on. So let's turn it off. So there is power to the motor, but the motor itself is not turning. You just hear a big hump. It's not starting. So we'll look inside and see what's going on. So right now I'm facing the back of the motor. Let me zoom in a bit to show you. There are two screws holding the cover here. But before I open the cover, I just want to make sure that I'm using this little device here, which is a voltage detector. You can either use this to detect if there's any voltages on the AC connector. That way, when you open up the cover, you're not exposing yourself to any electrical voltages that could shock you. I'm just turning this on. Now, I turned the breaker off and it's not buzzing, so we're okay. Now, I'm gonna get my wrench. You can either use a slotted screwdriver or a ratchet to open this up. So I'm going to use the ratchet. I'm just going to pause for the moment. Okay, so now I have loosened the two screws here, the one on top and the one on the bottom. I just pull on the cover like so. And then I'm exposing the back of the motor. As you can see, using my little tool here, there are no voltages, no AC voltages applied to the motor. By the way, this motor is hooked up to run on 240 volts AC. And all you have here is your terminal for your connectors, and you have also a capacitor. Why? The capacitor is used to start up the motor. What we'll do is we're going to check if our motor is seized, because you have bearings, two bearings inside the motor, and sometimes the bearings get seized and the shaft of the motor is not turning. So what you can do is just with your fingers, you see there's the tip of the shaft here. Try and turn it with your fingers just to see if it's free to move. I'm sorry if I'm hiding it right now, but if I take a pair of pliers just to show you, this is the shaft here. Let's zoom on this so you can see better. So you see here, there's your shaft. When the motor is operating, this part turns, and as you can see, with the pliers, I'm able to turn the shaft not freely, but I don't feel it stuck. I feel that it's moving pretty well on both sides. Okay, so that's a good sign. The next thing I want to do is check the capacitor. To check the capacitor, I have to remove two screws. So I'll do that and I'll be right back. Okay, so I removed the two screws, holding the bracket for the capacitor, and as you can see, the capacitor is free now. It has connections on the terminals of the capacitor, and I don't know if you can see it, but I'm going to zoom it in. That capacitor doesn't look very well. See now, I'll bring the camera closer. The capacitor is somewhat bulged on the top here. I don't know if you can see it. And usually the top should be flat, you know, like the bottom, and you see a big bulge there, and there's even a kink on the side here. That's not a good sign. That means the capacitor has overheated and it's probably opened. So what I'm going to do, I'm going to remove the connectors on the capacitor, and we're going to test it using a capacitance meter on my multimeter. So I'll do that right away. Just make sure though, like in this case, there is 3 wires. There's a red one which is on one side of the capacitor, and there's 2 orange wires on the other side. So you got to make sure that you keep in mind, take a picture if you're not sure, but make sure that when you replace, if you have to replace this part, to put the wires exactly at the same location where they were originally. So let's do that. Just using a pair of pliers, remove the first wire and the 2 other ones. There you go. Now the capacitor is free. So our next step now is to check the capacitor. Before measuring any capacitor, I always recommend that you make sure that there's no charges left on the capacitor. So what you can do is take a screwdriver and just short the capacitor. So it means that you just apply it on both terminals at the same time. So if there's any remaining charges, it's not gonna hurt you or damage your testing equipment. So once that is done, I just look here and it says that this is a 30 microfarad capacitor plus or minus 6% of tolerance, and it's rated at 370 volts AC. Just keep that in mind for later, and you can really well see that the capacitor is it's pretty bulged. So what we're going to do now is take our multimeter that I have here. This one is a cheap one that I bought on Amazon, but it has kind of very useful functions. It's made by the company Kai Wheats, model HT118A. You can get it on Amazon for about $45 when I bought it. I bought a cheap one because I use it in my shop, and it's lying around, so I didn't want to use the Fluke that I have downstairs. And what you do is you put this on the capacitance symbol here, which is used to measure capacitance, and we're going to check and see if our capacitor is still good. So I'm using one lead of the multimeter on the one terminal of the capacitor, and I'm putting a second lead on the second terminal, and you see it's not doing anything, it's not reading. So what this means is that the capacitor is faulty. It's acting as an open circuit, so it's not doing its job of giving a charge to the motor. The capacitor is used to give a boost of energy to your motor, so when it starts, it always requires a bit more current because it has a resistance, and the capacitor is there to give it a boost of current to start. So since this one is open circuit, it can't perform that action, so that's why the motor is just standing still and not turning. So what I've done in the meantime is I've ordered a new capacitor from Amazon, which has the same specifications, 30 microfarad at plus or minus 6% of tolerance, and this one is capable of handling 370 to 440 volts AC. The only difference, the height is pretty much the same, but I couldn't find one with the same size of the diameter. This one is a little bit larger than this one, so I hope it's going to fit well inside. I might have a little issue with putting the cover back, but we'll check that later. So the first thing I'm going to do is make sure that this new capacitor is working. So we do the same thing with a screwdriver. You make sure you just short the two terminals. That way, if there's any remaining charge, well, we won't get a shock or affect our equipment. And I'm getting my multimeter now to test this capacitor, and you'll see that if it's working well, then we should be getting a reading. Let's see now, one test lead here, the other one there. And we're measuring 30.52 microfarad, which is pretty good. It's well within the 6%, plus or minus 6% tolerance. Perfect. So the next step is to put the wires back the way they were. So if you remember, we had two orange ones on one side, like so. Let me zoom this in a bit more so you can see. Sorry about that. It's an awkward place to work, on the floor of my shed. And the second one was going here. Make sure they're pushed in well, and the red wire goes on the other terminal, like so. So what I'm going to do next is put this guy here and put the bracket to hold it in place, and I'll be right back. I was able to put the capacitor back, but there's only one issue, is since the diameter of the capacitor is much larger, well, a bit larger than the old one, the screw on this side here cannot reach the hold. So I gotta find a longer screw. I'll be right back. I was able to find a screw for this side that was longer than the original screw, since the diameter of this capacitor is larger than the original one. Unfortunately, the original one, the company that made it, Gen Tech, no longer exists, so I wasn't able to find the right size, the same size as the original one. But if I make a quick check here, since it is a bit thicker, if I just take the cover and put it on top, as you see, I'm going to show you this way. The cover is fitting pretty well, actually. There are no gaps between the cover and the back of the motor, so it should be okay. So now let's put these screws back in just by hand, just to make sure that it's not moving, and let's do a quick test. So hold on a second. Sorry if I'm moving the camera. So this is our motor. I'm going to be turning the breaker on. So this is the moment of truth, and then the switch. So let's watch. Oh, that's a good sign. That's a very good sign. So right now there's some air inside the chamber, but water should start pouring in pretty quickly. Sorry about my cover. And I don't know if you can see, but there is water coming inside. And she's pumping. And there you go. Perfect. Let's check here. I got some air coming out. So we've fixed our issue. Thank you for watching, guys. Hope it's going to help you fix your own motor and save on a new motor is worth like $600 here, so it's pretty expensive. So we'll see you again in another video. Take care.